Okay, hello everyone. Today we're going to discuss program requirements for BS in Cybersecurity Engineering. My name is Dr. Prakash Ranganathan. I'm an associate professor here at the School of Electrical Engineering and Computer Science at UND. I've been with UND for about 19 years, so I'm also directing the cybersecurity program for master's program in cybersecurity as well. So if you have any questions or concerns or anything that you want to bring out in cybersecurity programs, please alert me, or I'm happy to chat with you or schedule a call so we can go over your questions. And also feel free to shoot me an email, and I'll be in touch with you. So let's move on to the program. Before we get into the program, oftentimes I get this question about, what is the difference between a traditional conventional cybersecurity program versus cybersecurity engineering. At UND, we are a National Security Agency's NSA designated school for CAE-R, and which means that we have good programs and good research in cybersecurity, a good number of faculty, grants, and publications. So we are excellent. We are given a designation by NSA. So we are continuing to maintain this excellence in cybersecurity designation. First of all, for those who are not aware, and so cybersecurity in traditional cybersecurity program, it's a more like a CS flavor of a cybersecurity. Okay, you do a lot of coding based, learning to know more about operating systems from a defender and an analyst hat perspective. Okay, so think about something that a cybersecurity professional who notices a strange login attempts at 1 a.m. or 2 a.m. Right? So immediately, you need to go and block the attacker or investigate logs, what happens, or maybe its system is unavailable, what happened, or report the breach. So you wear an angle of a hat of incident response or SOC analyst, or who is there to make sure we have the right people who has the privilege access controls, and set policies in the identity access management, do some forensic of the logs, right? So that's what you do if you have a BS in cybersecurity, protecting systems, data, and networks from attacks. Okay, and whereas in cybersecurity engineering, you are actually wearing the hat of a builder and a designer. Okay, you actually spend time from scratch to see how do we build secure systems. Okay, whether you're looking at avionic systems or electrical grid systems or vehicular systems or space systems or drones, whatever, right? But you are discussing with a team of engineers and trying to see, how we could avoid all sorts of vulnerabilities, all sorts of making sure that we follow secure by design principle to make sure the design is robust. The life cycle of cybersecurity is robust when you design those systems, right? So you oftentimes you look at the, for example, the example says here, designing a smart electric charging environment. Make sure it's secure before it's installed. Adding encryptions makes the communication protocols are in place, and make sure the hardware chips are secure. Now, third-party vendors, make sure there's no supply chain risk, things of that nature. So you wear a systems knowledge, systems hat, when you actually do that. You probably, if you're going to be an electrical engineer and a computer engineer, and on the top of that, if you have where the, take the cyber engineering degree, then you have a kind of a more marketability. Or you're pretty sure that you want to do cybersecurity engineering, and where you have a combination of EE and some hardware and software courses, and you want to focus on the design aspect of security, then this is the degree that you want to spend. So in simple sense, if you really want to spend more hardware, more little bit of software and networks, then cyber engineering is ideal for you. On the other hand, you are a coder, a lot of coding. You love sitting in computers, a lot of coding, Python and shell scripting, a bunch of other things, and then from an analyst perspective, then a cybersecurity degree is appropriate. Okay, and that's the gist of these two different flavors of this, And typically, if you're a cybersecurity engineer, you work for utilities, whether power companies, or water utilities, or oil and gas, where there's a lot of domain knowledge is needed to really to understand how the systems work or the subsystems work, the interactions, the dependencies between various aspects of the pipeline of those OT systems from an operational technology point of view. At UND, we have about 126 credits for this program. We have designed this curriculum by talking to all the leaders in the country, different chairs, industries, So the program is very rigorous program. In the first year, you could see that you end up taking 17, 18 credits in the first 2 semesters. There's computer science 1 and 2, and there is introduction to cybersecurity engineering that you will be exposed of what is a cybersecurity engineering in general. So that may be a course for you to try if this is something that you want to get familiar with this particular program, and you still have traditional other required courses in typical other engineering like Calc 1 English, Calc 2 Physics, and so forth, Calc up to Calc 3 and differential equations, right? So you still go through those. Engineering is all about foundational math and physics, so which still you need to do, right? And I mean, I think in this case, you're going to take math courses in this particular program. And you're required to have 8 credits of laboratory science credits, which you have options to take from. And there is no sequence requirement, but you can take a combination of physics, chemistry, or biology. I have a slide on that, so you can pick your choices. What you want depending on what's approved in the slide. Okay. And then you end up taking in sophomore year circuits 1 some assembly language. You are exposed to new assembly language course, learning to more about hardware, and some linear algebra course in circuits 2 in the spring of sophomore year, and ethics course that you have to be taking in sophomore year. In the junior year, you focus more on electronics 1, some exploit analysis and development course, more about it's kind of a pen testing in some way. I think that's what you do in this course. And embedded systems, more about microprocessors, microcontrollers, computer network course that talks about computer network security, different protocols. And in the junior year, you actually, you're required to take 2 credits of co-op, okay, which means you may have an offer from a company that you want to work in a summer, either full-time or part-time, depending on, what the job is. It has to be related to cybersecurity. So you end up taking a cyber practicum. There is a small change in the course number, that I'm working on, but still it's actually a co-op credit. It's EECS 397. We want to have the same course number for co-op across all electrical, computer science, and cybersecurity. So I'm changing the co-op name. It's as, choosing EES 397. Still 397 course, but the designation is EES 397, not cyber, for ease of managing the course. So that's the only change that will happen. But it's still, you're required to take a 2 credit of co-op as part of the program requirement. And then there is a law and investigation course, CJ 320, that you have to take during a junior year. And then senior year, you take a capstone course, which is a year-long course, depending on what cybersecurity topic that either you choose a topic from an industry projects, or maybe you work with a faculty member on a particular project, on a research project. Your capstone instructor will tell you more when you come there at that point. And then you have some computer hardware course, another level of pen testing course you'll take, and some CPS and component security. When we talk about this avionics or grid systems or space systems, there are different components. You probably look at cyber as a cyber physical systems perspective. You have a computation, you also have physical I have to also understand the physical system as well. So I think this is a course that talks about component security and how you can able to integrate the different subsystems. What type of coupling do you need, loose coupling, tight coupling, and so forth. And then you have engineering system reliability course, that talks about how do you make sure systems are reliable under different uncertain conditions, what happens in the failure scenarios, how do you make sure, how do you evaluate those systems to make them reliable, and you also need to take a elective credits as part of the requirement for this particular course, okay, or this program. I believe it is 6 credits. If you can see, since this, my camera is hiding this flowchart, but we can send you the flowchart when you work with SEM advisors. Okay, so this is a rigorous 126 curriculum, 126 credit curriculum. So this is what it is. Okay. In terms of 4-year plan, I think was pretty much what I laid out, but it's a different view. You can also see a different flavor to this. I think in each of those semester, what you'll end up taking. So I have this also for your own convenience that's listed here. Going back to the list of approved lab science electives, you can pick any of the 8 credits from this particular list, which is the standard list for even the computer science program. So you don't have to follow a sequence, but you can take any of or any 8 credits out of these eight of this course. Okay, and okay, and co-op, we talked about that. Okay, what happens if we don't end up in co-op, right? And well, in that case, reach out to me and or any other cyber faculty. We'll open up in independent study or elective course that is more like a project-based thing that you'll work with the faculty to complete that course. Okay, you end up working with a faculty member, do the project, and submit a report. That's what the cyber elect one of those project, right? Is another we use the cyber elective special section course for that, but in addition to this, you still need to take additional 6 credits of cyber elective, if you go with that option. So this is the course I was talking about, EECS 397. Right now, the program is approved for Cyber 397, but the advisors are familiar that you end up registering if you are starting this spring. If you're in co-op, then you end up taking EECS 397. The common job titles that you may have for cyber engineering graduates is cyber engineer, embedded systems security engineer, industrial control ICS engineer, OT engineer, firmware security engineer, AI security engineer, network security pen tester, CPS engineer, forensic and hardware or reverse engineer, right? There are a lot of all these titles that you can able to get using cybersecurity engineering. And there are a lot of other companies who hire cybersecurity engineers, and here is the example of some companies that you may want to look at, and there are many more companies. Just an example sheet. Typically, they may say combination of electrical, computer science, or maybe cybersecurity engineering, specifically focusing on OT perspectives, and so I think this is not a robust list, but something to give you. So with that, we have Ashari Nunes is the advisor for cybersecurity for undergraduate programs, and Daniel is overseeing all advisors, but only if Dan comes into picture. If you have any really issues with the particular question that Ashari cannot answer, and of course, and I'm here as a director for the program. If you have any questions, you can always shoot me an email to help you. Okay. So I hope this quick video helped understanding the program, its purpose, and I welcome your questions, and any feedback that you want to offer us to let me know. And we are here to support you and make you understand and see what we could do to make you successful. And so reach out to the faculty member always to make sure that if you have any questions, and I'm there to help you and support you as you need it. Okay. Thank you for listening, and I look forward to working with you and look forward to your email. Thank you.